All right, so let's look at a slightly more difficult implicit differentiation problem that also utilizes some of the other derivative skills that we have. So x to the third times sine of y plus y equals 4x plus 3. And our goal here is to find the derivative, or dy dx, derivative of y with respect to x. All right, so notice this one would be probably next to impossible because we have two instances of y and one of them's trapped in sine to solve for y, but it doesn't mean that we can't come up with a derivative. And the biggest piece here we might want to notice is where we have x to the third times sine of y, we're going to need product rule. Everything else looks like an individual term, so those should all work out pretty nicely. We'll just have to be careful when we do product rule. This is like our f, right, our first part of product rule. And this is our G, our second part of product rule. And probably still a good idea to write down what our choices for F and G are. All right, so what we're going to do is take d dx, the derivative with respect to x of the entire thing. Most of them will work out without needing that little chain rule piece, except for when we run into a y. All right, so the derivative of this using product rule, so we'll be thorough on this first one and write out our parts. Here's our first term, and the derivative of the first term with respect to x is 3x squared. And then our g, our second thing that's multiplied for product rule, is sine of y. And we'll have to be a little careful. You can't take the derivative with respect to x, but if we take it with respect to y and add in our little chain link for chain rule, the derivative of sine of y is cosine of y. And because we did that y instead of x, we'll have to add a times dy dx. Probably if you're going to write out your pieces of product rule like this, it's a good idea to just put that in there right away so you don't forget about it. And so for this derivative, we have first times derivative of the second, second times derivative of the first. So we'll just write out our pieces. So x to the third cosine y times dy dx plus sine of y times 3x squared. So 3x squared sine of y. And then we can just continue along with the rest of our derivatives. So the derivative of 1y is just 1. Don't forget we just took that with respect to y and not x, so we have to put a times dy dx on there. So 1 times dy dx. If you ever see somebody not write the 1, right, it's times 1, you don't have to, but that's where that came from. Derivative of 4x is just 4, and derivative of plus 3 is 0, which you don't have to write if you don't want to. And so now we're done with all of our derivatives, but we have to get the dy dx's on the same side as each other. So we'll take everything, every term that doesn't have a dy dx. So notice this big term has a dy dx, right? That's all multiplied by each other, so it's all one term. And this one has a dy dx, so we could subtract this one over to the other side. And maybe since both of these two have a dy dx, I could factor it out front. Just get ready for the next thing that's going to happen. So x to the third cosine y plus 1, because right, this was our 1 times dy dx. And then I'll subtract that term to the other side of the equation. 4 minus this. All right, so then very last thing to get dy dx by itself is it's multiplied by this whole quantity. So if I divide both sides by this whole quantity, over here it will cancel, and over here it will be over x to the third cosine y plus 1. And so we're essentially done. Maybe not a bad idea to clean it up, make it look a little bit nicer. So dy dx equals 4 minus 3x squared sine of y all over x to the third cosine of y plus 1. So without solving for y, we are still able to come up with the derivative of this function. And also pointing out you can use chain rule, quotient rule, product rule, all the rules we already know with implicit differentiation. All you have to be careful about is your variables. When you're taking the derivative with respect to y and not x, or really any variable that doesn't match up, you have to add that little chain rule piece in order to be able to do it.